we have 100,000, maybe 10,000 with the ASA Terry Tao.
There might be a paper with 5,000 authors. If we had an AI that actually gave confidence levels to its outputs, that would already be much more scientifically useful.
But additionally, we have industry leaders from NVIDIA, from OpenAI, from Amazon, and from Microsoft, and many more that actually are very interested in working with us.
Creating a pipeline from basic science to research development, and then to actual commercial products.
Yeah.
For me, the future of mathematics actually resembles in many ways the trajectory of developing software.
I'm Jay from Kobe AI. We're like one of the biggest tech media in China, and I'm the editor of the company. And sitting beside me is our editor-in-chief, Li Gen.
Okay, nice to meet you.
Yeah, so I want to say that first, it's really great pleasure to have you here, since it's really exciting moment. Thank you so much for joining us today. And I believe there must be a lot of Chinese fans looking forward to this conversation. Based on outline, I will start with a few questions about your recent work on the AI for science. And then we will move into the math, which is Terry's area. And finally, we will talk about some broader trends like the education, like the future of artificial intelligence. So does that sound okay to you?
Yep, sounds good.
Well, so let's just get started. First off, I want to say that really congratulations on the launch of SAIR Foundation. So can you tell us about the core motivation, the reason that you launch and co-found this alliance? So how about Terry, you can go first, and Chuck, you can jump in after.
Sounds good.
So I think AI is going to transform science. I think there's so much potential to accelerate science and do really original workflows that we just can't do or can't even imagine right now. But if academics don't have the tools to use it properly, there are just so many bad ways to use AI. It produces rubbish if you don't know how to verify it. So we need research into how to use AI properly and how to run really good pilot experiments that other scientists can use as role models. Traditionally, universities and research institutions and government sponsors have funded these type of activities. But in these times, I think private support is also really important, and it can be more nimble, and we can run really innovative experiments. So I'm very happy to be involved in founding this, helping to found this foundation to try all kinds of exciting new things.
And actually, echoing Terry's point, I think right now I've always have a passion for working with great scientists, including Terry here. So I'm really excited that when we start this organization, having Terry as my co-founder, along with a number of Nobel Prize and Turing winners. And how I feel about this AI is there's like so much. Terry already mentioned about the academics area, but I've been very involved also both in terms of academics as well as the industry. So that's why we're very excited. In fact, you can see that on the SAIR AI and science kickoff. We have, of course, Terry, we have a number of academic leaders, but additionally, we have industry leaders from NVIDIA, from OpenAI, from Amazon, and from Microsoft, and many more that actually are very interested in working with us. So I'm very excited that we'll be able to combine both the academia as well as industry. So there's a lot that we can do. So very, very excited.
So I noticed that SAIR Foundation is an organization mainly focused on AI for science. So I have a question that what is your part of the current AI technology? So why can't we just use the models from OpenAI, like the LLM, directly on science? Why do we need to develop like new ways, new solution?
Right. So we have been trying to use the standard LLMs that these tech companies produce, and some people have made some success out of them. But on the one hand, they are not always reliable. Some of the outputs they produce are just incorrect, and so we would like more scientifically verifiable, trustable AI. Also, some of the outputs that they generate are not interpretable. They may come up with a great idea, but they don't tell you that actually their idea is coming from a previous piece of literature that is in their training data. And science is not just about solving problems, but connecting it to what other scientists have worked on. And so being able to trace back what you're doing to the past, to what other scientists are doing, and how to connect it to the future, to what how can you explain how to modify these solutions so that other scientists can build upon them. The LLMs that the commercial tech providers provide, they can sometimes do that, but if we had more tailored AIs specifically for research, or if we could find better workflows to sort of learn how to always verify the outputs that the AIs produce, or always check how it connects to literature, then it would be much more powerful. It could be that the solution is to actually just incorporate these standard AIs in the right framework, and what the kind of research that SAIR might support is just how to design the right kind of rigorous verification framework that you can put in these AIs and make them much more useful for science.
Yeah, and I also echo that. I think that, I mean, on a day-to-day basis for just kind of maybe writing or those essays and whatnot, I think, AI models could be pretty good. But certainly when we need to go into very deep technical domain expertise, and part of the issue, as you guys all know, they train on data, on lots of data. But the thing is, to be honest with you, on very difficult and technical issues, as many, these data points out there, right? So that's why we need, scientists, frankly, to work with us. So that, just like Terry mentioned, I was looking at a recent example of a friend of mine who's also a famous person, and actually the model itself hallucinates. It says that person supposedly is like 70, 80 years old, but it says he's 50 years old. So you can see and we're actually, Terry and I have talked about how we can actually, in fact, we can look at these examples, we can trace back and we can verify, well, that's not correct. And so we need to work on these. Well, actually, in fact, we need to work on some of these issues. And we hope, and our goal, of course, is to make AI better. So that we can actually apply and everybody can really use it. And we call the word democratize.
I can give you one simple example. So when a scientist says something is true or not, they also often say how confident they are. I'm very confident this is true. I'm somewhat confident this is tentative. But AI often, it's always 100% confidence and nothing else. And that's not what we want. If we had an AI that actually gave confidence levels to its outputs, that would already be much more scientifically useful.
Next question I want to throw to Terry. And we just talk about the difference between SAIR Foundation and the current LLM solution and the science. So I noticed that most of the industry now focus on scaling by adding more data, making big models. But I see that SAIR Foundation advocates like the scaling of the science of AI. So what does this mean?
Yeah, so the current sort of strategy of these big tech companies is every problem that can be solved by scaling. Well, not every problem, but and so far this has sort of been a very successful strategy. If you multiply the amount of compute and training and data by 10, the intelligence goes up by quite a lot. I think at some point that will hit a wall, and well, first of all, there's no more data. We have already used the entire internet, and there also might be no more electricity at some point. Right now, these AIs can solve very difficult problems, but extremely inefficiently. Like a human mathematician can see 10 examples of a math problem and get the idea and figure out how to solve another one. But these AIs, they need to train on millions and millions of examples of data, and they don't always get it right, and so you have to run them hundreds of times before they finally get it correct. So I think that there's a lot of untapped potential in just making these tools much more efficient. And for science, we may not need the fanciest models to do everything. There could be some very specialist tasks which actually some low power, cheap models that you could even run on your own computer might actually be enough. But the biggest companies, that's not their market. They want their giant universal AI that does everything. And maybe for research, actually just some tailored specialist tool is what's needed. And so we need some way to help develop that, and I hope SAIR plays a role in that.
I think Terry is an expert on that, so I just echo everything that he said on that.
Right.
can take it as that in the area of AI science, we need better principles rather than just bigger models.
Yeah, so we need to be able to evaluate trustworthiness, confidence, interpretability, as I said, and just we need to be able to find out ways to work with the AI. So the way these models work often is that you give them a prompt and they just give you a full solution. But sometimes you don't want just the solution. You want to understand the process of how you got there. You want to offer some input halfway. You want to be able to understand it. The tools that these tech companies have provided are already very useful, but they weren't really designed by the scientific community. So they're kind of what we want, but not exactly. If we had some way as scientists to develop tailored tools for our own purposes, they would be much more broadly adopted. A lot of scientists are still very reluctant and resistant to use these tools because they've seen all the ways they fail, and they don't quite solve the problem that you really, really want.
So actually, I'll echo on that point because this is actually exactly, I think, about the trustworthiness of data. Because another good friend, which is actually John Hennessy. He's a Turing winner. He's also chairman of Alphabet as well. So we've been working closely in terms of sort of on this supported effort. One of the things he really thinks with science, it's also improving the quality of data, right? Which is an issue right now, because if those quality of data, hallucination, those other issues, right? The trustworthiness, and this is also very interesting for you, for the audience here, because I know you have a global audience, right? So people in the U.S. versus actually people the rest of the world, certainly like let's say Japan or China or other parts of Asia, generally there's a general trust on those data. It's closer to more like 70-80%. In the U.S., unfortunately, the trust on AI and data on that, it's about half of that, right? So you can see why I think Terry mentioned about how a lot of certainly like OpenAI as an example, or xAI as an example, or these number of large language model companies, they all want to work with us to really make sure that we advance AI. That the points, exactly the points that Terry mentioned about. So that's why I think it's very important for us to work on that together.
For the next question, I want to ask Chuck to answer it, because I believe that you may have a lot to think about this. So as science and AI, we know that it can lower the barriers to the scientific research. So what changes do you anticipate this will bring to the industry or to the global research landscape right now?
Yeah, no, thank you for that question. I think the ultimate goal is, I think, working with great scientists and some leading scientists in this area, is to make sure that we improve this whole the AI model itself, so that as we already mentioned, that there's this trust factor, so that people like the day-to-day, your grandparents, or hopefully your mother and grandparents, be able to use and trust the AI models, right? I think that's really sort of the goal, and I think to get to that point, right now, that's why we're working and doing this AI and science kickoff, because we're working with the leading scientists and industry, so that we can all working together and learn from each other, and then at the same time, to push the envelope to make it better, and of course the ultimate goal, as I said, simply put. We mentioned democratize AI, but ultimately, it's all make it everybody will really use it, like reliable. I mean, like car, for instance, cars are very reliable these days, right? So we want to make it as such a useful tool for everybody.
How will the SAIR Foundation help to navigate or accelerate this transition specifically?
And that's also sort of the focus of the SAIR Foundation, right? Which is we have academia in partnership with the industry. And also part of that is, of course, to do all these things together, we bring everyone together and identify areas where, say, academia in our case, right, we lack the computing power, right? And in the industry side, they have, of course, a lot of, they have a lot more computing, they have more money. And so, but the thing is, their model is not there yet, right? So they would need to work with, our scientists, Terry, other leading scholars in that space to improve the model. By all us working together, and then additionally, Terry also mentioned, right? Given the research funding cuts in the federal government, we need a lot of people, community, to all working together, donors, investors, philanthropists, foundations, right? All of us working together to support, frankly, the research that these brilliant researchers are working on. And I think that's the way how we feel that would help us to push the envelope better. But Terry, I don't know if you want to make any additional point to that.
I agree with, so for many decades, the model was that academics were supported by by federal funding in the US at least, and industry, so academics would produce basic research, industry could use that basic research. I mean, everyone could use that basic research to then build intellectual property that they could develop, they could patent, and they can commercialize. But the pipeline is very slow. The academics are not really focused on marketability, and the industry is not really focused on fundamental questions. That they just want whatever will make them money in the next quarter.
Right.
So the system kind of worked, but it was not as efficient as it could be, and so it's been destabilized now because of the funding cuts and also massive overinvestment. I mean, so now AI is absorbing a huge amount of investment. So this is, it's chaotic, but it's also an opportunity to rethink what is a 21st century way of creating a pipeline from basic science to research development and then to actual commercial products.
Yeah. Exactly that point is right now, it's really a historical opportunity because I think that when we talk about in the past, I think academia, universities, academia are slow to respond because they have the federal research funding and other support. But right now, given the deep cuts in the federal research funding, certainly especially in the US, we see this as an opportunity to step up and support other great researchers and work with them on the industry side. So that's why we see it's in a very good place at the right time, at the right, right moment.
I believe that must be a very, very fascinating future. So we just talked about, I remember, Chuck, you said that the quality of AI, of the models, mainly depends on the data. And that's what the companies, they lack of now. So they need the help of the academics. So do you think that AI faces similar changes across different fundamental sciences because of the data? Or does the difficulty vary a lot from the field to field?
Certainly, we've seen that the sciences where AI has managed to make the most progress is ones where they have the highest quality data. So, for example, one of the most celebrated achievements of AI is protein folding, and it's because there was a lot of federally funded actually work to collect lots and lots of high quality data of existing proteins, and it was a decades-long effort, and this is why we can solve that one problem. But other problems, for example, like modeling a cell, which seems like almost a very similar task, we don't have the data for that. Yeah, AI is extremely data intensive in a way that no previous ways of doing science haven't been. A problem, once you run out of data, high quality data, maybe AI development will come to a halt. There is a hope that you can generate synthetic data to replace as a substitute for real world data. But if it's not of sufficiently high quality, it could actually make things worse. So that's actually a really important area of research. How do you generate high quality synthetic data, and how do you avoid data pollution of just junk data, making existing databases much lower quality?
Chuck, I'm wondering what's your take on this, and do you think that AI faces similar challenges between different fundamental sciences?
I absolutely think so as well. I think that we, of course, like you can see that in the different disciplines, right? I think that we all feel that mathematics is a foundational science, right? A lot of the models, including like you say physics, or like astronomy or different areas, right? We need to have the foundational model, to kind of tackle the different hard issues. And to Terry's point, right? Perhaps synthetic data may be one area that people are looking into, but if the data itself are not at the level that's needed, then it's going to be garbage. I think there's a saying that it's like garbage in and garbage out, right? So I think that's why, going back to the same subject, which is AI and science, right? And I'm very proud, I think, and Terry too is the same thing, that we actually, with this February 10th event, we're gathering the best minds. When I say best minds, of course, we have the best minds from UCLA, which I'm very proud, and best minds were also from Berkeley and the West Coast, and Caltech, for instance. But it's actually throughout the U.S. and throughout North America in a way, because we have leaders, we have leaders from UPenn, University of Pennsylvania. You have leaders from Brown University. We have folks from Cornell University. So and we also have folks from Canada, because our one of our keynote speakers, Rich Sutton, just won the Turing Award, and he's the father of reinforcement learning, and he's from Canada. So we can say that we actually really kind of cover North America in a way, Terry. And so we're very excited that when we actually work on this, it's not just us here in California. It's not us just here in America, but really globally in a way. In fact, I also just came back, by the way, from a trip in Asia. So I'm also very proud that I've talked to folks in Singapore and Malaysia and places of such. So truly, we're very, very excited. We have these global efforts.
Yeah, that's an exciting moment every day. So can you give us some more specific examples, like how will the SAIR Foundation support this kind of cross-disciplinary or cross-countries collaboration between scientists in this context?
Well, I'll start, and maybe Terry can chime in. So one of the things that we're really excited about, and this has actually been something that IPAM and UCLA here has done a very good job to begin with, by the way, which is, they're actually having these different seminars and whatnot on different subjects, right? And I think Terry can talk more about that. But the way how we're looking at it is, as an example, we are, I was reason why I was in Singapore and Malaysia was actually there is a winter retreat that is organized by Open Mind. Open Mind it's a nonprofit organization started by, I just mentioned Rich Sutton. And the whole point of that is to, train these young researchers from all over the world. I mean, but of course, that initial stop is in Asia. So there are lots of people from Asia. We have folks from Singapore, Malaysia, China, the Philippines, Korea, and so many parts of Asia that gathered together. And it was really kind of looking at sort of the different models, efficient models, learning from each other, and really kind of, getting the great young minds to identify where we should take AI to next steps. So that's an example of the cross-disciplinary or cross-regional framework, if you will. But I think, Terry, you might want to mention how about the fantastic effort that IPAM has done over the years, right, in different disciplines.
Yeah. So SAIR is just starting this year, but IPAM has been around for 20 years.
Yes.
IPAM stands for the Institute for Pure and Applied Mathematics. It's an NSF-funded institute. It still is NSF-funded, but now we are also diversifying our funding structure. What it does is its signature programs are these long programs where we spend 3 months inviting students, faculty, and sometimes also industry leaders from several different fields, which are related on a common topic, maybe multi-scale analysis or the science of the heart or self-driving cars. We had a very early workshop on deep learning before it all exploded. We do many. We're not exclusively AI, but we have done many influential events on AI. So we bring together communities that would not normally talk to each other. In the past, we have mostly focused on academic communities, so pure mathematicians, applied mathematicians, scientists. With the context of SAIR, we hope to make more connections with industry and actually focus on actually more immediately practical applications rather than, our specialty is still very much mathematics, but I think we are interpreting mathematics in a much more broadly than we are before. So yeah, we're going to experiment with the support of SAIR with different formats, different ways to bring more communities together.
And so echoing that point, that's why we think we actually have such a perfect partnership, right? Because IPM and UCLA has done so many, and Terry mentioned the last 20 years. And so right now, with this combined effort, we're gonna take it even further. And so that's why we're very excited about this launch, the AI and science kickoff.
So Terry, next question is for you, and I get Chuck can jump in after. So we just talked about how AI will affect the scientific research and how will self-foundation participate in it and lower the barrier of science research and construct a better future of scientific research. But I was wondering, other side, will this kind of could the development of AI for science affect the current AI solutions? I mean, could this be a better AGI way?
That is also a very promising direction. So, as I said before, one of the biggest weaknesses of modern AIs is that they hallucinate, they say things that are just incorrect, and often there's no way to check that. You just have to trust them, or you need to be an expert in order to evaluate. But in math and science, particularly in math, you can verify the outputs that these AIs generate, and you can keep them honest. And maybe through that, you can train the AIs to make fewer hallucinations. Within the confines of doing mathematics or doing science, if we can teach AIs or find ways to find frameworks that make AIs much more reliable, that may generalize to other contexts. So maybe in medicine or in law or when making financial decisions. Right now, it is too dangerous or too risky to use these AIs to trust them completely. I mean, maybe you can use them to make suggestions, but you can't sort of give them the keys to drive something for which actual lives or monetary value is at stake. Yeah, but if we can figure out how to make AIs reliable for science, then maybe they will transfer to much broader.
And I really think that's very important too, because of course the financial I can rely on my financial data on AI right now.
Yeah.
I don't think most people would, right? Because these are very sensitive things. Also medicine, right? Yeah. These are things like medicine as an example. It's a life and death situation, and maybe certain. Reading, I know that the X-rays reading, for instance, but there's certain key things in medicine that are very inherently, just very important. So a lot of these mission critical things, we hope with what we're trying to do, AI for science and science for AI, that would, hopefully one day, and we hope that sooner than later, that with our efforts that we can lead to those, those aspects.
Math in particular, I think, is the safest place to experiment with AI. So, if you use AI for a medical application or a financial application and it screws up, you are in big trouble. But, if you ask AI to solve a math problem and it didn't solve it, you just try again. I mean, there's almost no harm there's no downside to applying an AI to math in particular. So I think math is a place to start to run these experiments.
Right. Right, and also related to math is because the compute power, it's actually we can use a lot less, relatively speaking. That's relatively speaking, right?
Right.
And then we can prove and do all these experiments, if you will, and to get to where we want to be.
That's right. We don't need So AI is being used for drug design, for example, which is a very important potential application. But clinical trials are extremely expensive. And time-consuming.
That's right.
So while it's a very important application, a future application of AI, it makes much more sense to first develop these AI on something like mathematics, where you don't need to spend $1 billion to see whether your solution worked or not.
Yes.
Then let's dive into the researchers, the current situations of researchers under the AI age. Let's consider that, Chuck, I want to ask this question for you. So let's consider that the higher research levels abilities such as taste are built on the fundamentals. So, and now the AI may remove those key steps in young researchers' growth path. Right. So I'm wondering, how do you view this argument?
So are you saying that like researchers will be one day out of jobs too? Is that what you're saying?
Yeah, some kinds, but I'm worried more about if we need to start from the scratch. I mean, start from bottom to do the basic works to become a better scientist. If AI now can actually do this work, so how where can we learn those knowledges?
Maybe Terry, you can chime in on that one.
I think yes. I think what you're saying is also a concern of mine. Is that right now AI is now capable enough to do a lot of the tasks that we used to assign as training, or that we do assign as training to junior faculty and students. Like starter math problems or minor roles in a lab experiment, or doing literature search, things like that. And those tasks now, a lot of them can be automated. And so it's tempting to not give your graduate students the task of please review all the literature on this problem, or please do this very tedious calculation, because it's much faster to go to the AI and do it. But that training is very important. I mean, the senior researchers like myself, a lot of our experience and expertise came from doing this menial labor. So there has to be a trade-off, a balance. I think we have to be mindful to keep giving our junior researchers crucial job training opportunities, even if some of the training can be done. Some of the tasks for training can also be done by AI. Once they have reached enough proficiency, then it's safe to say, okay, for the rest, so okay, you've done 10 experiments with this chemical. Now that you use your automated lab to do the other 900. So we need to find the balance between training and automation. Not everything should be automated, for sure.
Yeah. So on that note, I think that we've also talked about how even right now, even of course, we mentioned, we can't rely 100% on AI. But even with that the case, I think that people are finding shortcuts, and I think that we mentioned about like even this generation, people are not thinking critically about a lot of these data points, a lot of these issues. They even say, "Hey, AI, give me some suggestions." So they're bypassing that aspect, which also is sometimes we need to be. I mean, that could be concerning as well, right? Because and that's why how we set up, and we're also very proud of that. That's why we have the leading scientists in our field to be part of this effort to launch this, because they have had, like Terry, they have had like other Nobel Prize winners. They have had the training, the vigorous training to go through that before where things are. And this is of course AI. It's only been in the last a few years of phenomenon. So hopefully by having this in a way, I would say somewhat of a mentorship setup, that our senior scientists working with the young and fantastic, talented young scientists, we'll be able to develop a better way, a better model, and better platform, frankly, to move things forward.
Right. It can work both ways. So analogies with calculators. When calculators first came out, people worry that now the kids will no longer learn arithmetic because every sum or multiplication they just use their calculator. And to some extent this is true, but first of all we figured out that we should still teach our kids how to add and multiply by hand before we give them the calculators. Right. But also, once you have calculators, you also find that some kids will just play with the calculators and they can discover patterns in numbers that they wouldn't have found without the calculators. So these are not just tools for making you dumber. I mean, they can also help you play and explore. And so we just have to figure out how to use them properly.
Yep, absolutely.
So I'm wondering, does that means the taste will be much more important in the future? Because you just mentioned the example or calculation, the calculates. So if AI will also replace many of now current workflows and abilities of researchers, what kind of abilities and traits do you think is more important?
That's a great question. I think in the future, we're going to work in much bigger teams than we are now, and much more diverse teams. So academics, industry people, mathematicians, scientists, AI, humans. we're going to have to learn how to work in large groups. So traditionally science often was done by lone geniuses in a lab or something, but it's very much a team sport. Yeah, and so communication skills, soft skills become important. And yeah, as you say, taste, being able to come up with some vision and then maybe try to flesh it out with some AI tools or some human collaborators. Yeah, I think we will. It will be there'll be more division of labor than in the past. So science, in many ways, at least mathematics, hasn't changed much in centuries. It's almost medieval in some cases. You have a master and an apprentice, and you work by hand on one problem for several weeks. And everyone gets involved in every step of the process. So you have to check the details, do the computation, come up with the idea, write the paper, apply for funding, give talks. But in the future, there'll be large projects, and different people do different things. So one person might be the vision guy, and they will describe the long-term aims of the project, and some people will be the ones who use the AI tools, and others will sort of manage all the people and make sure that everyone is working on something useful, and another person might be good at explaining what's going on. So I think we'll see a very diverse types of skill sets for doing mathematics or science in the future.
And I echo that because I call myself an aspiring scientist. And when I say that, it's because I actually am very fortunate. I'm surrounded by brilliant scientists, mathematicians like Terry and other folks. But the fact is, frankly, my training wasn't in science. It was more on the business front. But the thing is, I'm very encouraged because I heard another very successful entrepreneurial friend who built multi-billion-dollar companies. And he told me that his best prompt engineers, for instance, it's not engineering background, it's actually accountants and lawyers and people with actually these other backgrounds. So that's why when I say, as an aspiring scientist myself, right, I'm hopeful that one day, through technology, through AI, I'm not sure, I don't necessarily think that I would get a part, but certainly I'll be able to get involved with this exciting research with everything. And that's the point about democratizing AI, by the way.
Yeah, a lot of the projects that ICAM is running, and hopefully SAIR will begin sponsoring. Actually, SAIR is already sponsoring.
Yes.
Are these very collaborative projects where we're doing mathematical research, and we're taking contributions from professional mathematicians, from students, from people, from scientists in other fields, or just members of the general public. The barrier to entry to do science and math is lowering because of AI and these other tools, and that is one of the exciting positive aspects of this technology.
Yes.
I'm wondering, so what is the landscape of their trends? Because if you say that the AI will lower the barrier to scientific research, so what will that kind of future looks like? Does that mean even my little brother studying in middle school can publish the paper on Nature in the future?
It could happen. I think he might be one of there might be a paper with 5,000 authors. And they each contribute one little thing, and I can definitely see. Maybe your little brother playing his part. Who knows? I mean, there are math problems recently that were unsolved, and there was a teenager high school student with an AI, and they found a solution. It wasn't the most important math problem in the world, but it was a new solution. There are examples of non-standard ways to make progress in this field now. Who knows what will be more common, what won't be though. But yeah, we have to experiment and try all kinds of things.
Right, and I think to your point, I would be very happy that if you're a younger brother, or many other people with younger brother or sisters for that matter, right, be able to do that, and including myself, which I think traditionally, as I said, I already mentioned the example where traditionally I may not have the engineering or the strong STEM backgrounds, but for people who, as an example, non-STEM people, to be part of this contribution and make our world better, and that would be very powerful.
So next question I want to ask Chuck. I think this is more like your alley. Can you give us some specific examples based on the past discussions that how will stagnation support the growth of young researchers in the future?
I think that's an excellent question. How would we actually support the growth of young researchers? This is actually a passion of mine, by the way, that I've actually been a mentor over the years. From a college, we actually have one of the most successful mentorship programs at UC Berkeley, right? Because I'm also the head of the Alumni Association there. And also I've actually had mentor programs at, my friend Steven Schwartzman have something called Schwartzman Scholars. And the last, 5 years or so, working with, my other organization there started with 5 Nobel Prize winners, as well as actually John Hennessy's been a co-chair, of that organization. Has been mentorship of young science PhDs and postdocs. So what I've seen, what I observe in terms of like training these young minds, I think first of all, it's always great to give them role models, if you will, right? Because why? Because a lot of us, including yourself, all of us, when we were growing up, we look up to our parents, right? At home. And then once we started school, of course, we look up to teachers, right? And then once you're, say, outside of that, then we actually look up to other role models in society. So I think that's why I think it's so important that we are gathering these great minds together to begin with, because all of them have been tremendously successful in the different areas, right? And Terry, in his example, is his mathematics. Another example, Randy Sackman, which is our founding advisory board member, he's in medicine and biology, right? He's the Nobel Prize in biology. And then also as part of another founding member is, we have Barry Barish, which, by the way, he is taking Barry 100 years to prove out that energy could be in the form of gravitational wave. So that he proved it out around 2016, and in 2017 he won the Nobel Prize. Right? That's one of Einstein's seminal paper, E equals mc squared, which he indicated, like the particle aspect, which is proven a long time ago, but it's taken 100 years on proof of gravitational wave. So those are examples where we have these amazing scientists. They serve an example, and they would actually share their insights about how do they get there. Right? So I think on that mentorship aspect, I think that's very important. At the same time, we will be, and I think this is actually also a very important thing, because when we talk about the research and the research funding cuts, in fact, I think the cuts especially affected is the young researchers, right? So. They're very much affected because, I think Terry and others, they are already very accomplished, right? So they would, of course, get a lot more, they would get funding. And people want to support, a lot of people want to support your efforts, Terry. I'm so encouraged, right? Right. But the issue, the core to the issue is the young scientists. They're really at the, it's not like they're nobody, but certainly they're starting their career, right? So imagine that. So that's why I'm so passionate to work with you, Terry, and our founding team, right? Because these are the people that we need the help the most. And so that's why we really need to get this message out. Right? How they do that. So the example is, one day we want to have not just one, we want to have 100, 1,000, maybe 10,000 with the ASA Terry Tao. How's that? I think that would be a great example if we can do that. Yeah. Right? Wouldn't you want that? Wouldn't you want that? Of course. Yeah, Terry is very unique. There's only one. But my point is, hopefully, with AI, one day we could like 10,000.
Yeah. Well, SAIR, SAIR is just one organization. It can't do everything.
Right.
There's a great need to support the next generation with fellowships and grants. So I think SAIR will have one or two, a small number of targeted fellowships, but we can't take over the entire training of the entire workforce. But there are other things we can do. So I think through IPAM, we can support some summer schools, some public outreach events. And as I said, some of these collaborative crowdsourced projects naturally involve younger people, and some of the junior people can even take a leadership role and sort of claim one part of the project as sort of and be a sub-lead. So there's a lot of experiments. Hopefully, the things we do can serve as an inspiration for other organizations to also step up and have this very important task of supporting the next generation.
Absolutely.
So I believe that this must be a very exciting moment for all the young research in the world.
Exciting is one word for it, yes.
Yes, indeed.
Terrifying and exciting.
Yes.
This part, I want to move into the mathematics, and I guess that will mainly be the Terry's part. Recently work, what's your recently research, and is there any interesting topics that you are really fascinated about recently?
Yeah, so my work is still maybe 50% kind of traditional pure math research of the type I've done for 20, 30 years. So I find patterns in prime numbers. I try to see what's the difference between a very periodic structured pattern, a structured function, and a very random function. I play with differential equations, like fluid equations. Although increasingly, I leave it more to my co-authors in the younger generation to sort of push the envelope on this. A lot of my research nowadays is tied with all this new technology. I'm very interested in new ways to collaborate to do mathematics. So I've been involved a lot in formalization, so ways of converting to doing mathematics not in the old pen and paper style, but where our proofs are all written in these computer languages that are automatically verified. And then you can, and then this allows you to work with AIs, allows you to work with other humans who you've never even met before. And previously, if you worked with another stranger doing mathematics, you may not trust the answers that they give you. But if it's all in this verified language, it doesn't matter. And so we've been able to collaborate. We can. I've had projects with 50 people, who very few of them know each other, but we can solve this massive problem that no one of us could have done on their own. I'm experimenting with ways to use like these AIs and formal proof assistants and just modern borrow a lot of techniques from modern software development. Using things like GitHub and unit testing and quality assurance. And I'm learning all the tricks of software engineering to somehow create mathematical engineering. So yeah, I'm running a lot of experiments like that. Not all of them will work, but even knowing that some things don't work is also valuable information.
Yeah, Terry, it seems like that you are always embracing the new technology in your current research workflow, and that's the interesting part. So it's like it has been like half a year, I guess, since your interview with Lex Fridman. And I'm wondering that have your view on AI changed during this time, or have you come out with some, the new workflows, the new research solutions?
It's stayed more or less the same. I mean, AI for math has developed just a little bit faster than I was expecting, but there's still a long way to go. And I think I'm beginning to see the rest of my mathematical colleagues, they are coming around to the fact that AI is coming. And so there's a lot more openness to experimenting with different ways to use it, and to figure out what works and what doesn't work. What's somehow missing right now is that you can either kind of have 100% AI in your life or 0% AI in your life. But what's missing is sort of these hybrid things where you still do a lot of research in the traditional way, but then there are just some aspects of research that you offload to AI. And there is some balance in the middle that we haven't quite figured out exactly the best way to do it. It's like the internet. The internet is great, but we don't use it for everything. We still enjoy meeting friends and talking to people in person rather than on Zoom or whatever. But sometimes we have to. Like we're meeting remotely right now. So we have learned when to use the internet and when not to. Well, okay, some people maybe still struggle, but okay. And we'll need to find that balance with AI as well.
So I echo that. Actually, I want to kind of add to what Terry mentioned, because when he mentioned about how his colleagues have embraced, more and more people have embraced AI. In fact, that is actually the case right now, because in our in-person event, we have hundreds and hundreds of people who are wanting to actually wanting to come, but we really don't have enough space for them. And of course, we want to, the fact of the matter too is we want to balance out like 50% academia and then 50% industries and other entrepreneurs and whatnot. So frankly, I want to say, I echo that point, Terry, that there are lots of people in academia, including mathematicians, who actually want to come to our event February 10th, but not enough space. So that is also something that's kind of echoing your point, that more and more people embracing it.
We will have a live stream as well.
Yes.
So after next question, I think there will be many people interested. So Terry just told us about the work you are dealing with recently, and you are also mentioned that you guys in the lab are or embracing the artificial intelligence, in your current workflow. So, as one Terry, you are one of the world's greatest mathematician, and I believe that there are also a lot of top tier mathematician around you. So I wonder about how do you use AI in your daily work?
It's almost mundane. I mean, I use it a lot for kind of secondary tasks a lot. So like literature search now, if I can't quite remember how something how a piece of mathematics goes or how it relates to something else, I just ask an AI. If I need to generate a graph or compute some data, I just ask an AI. I autocomplete a lot in my text. I can write a paper and the 5 steps, and I write 2 of the steps, and sometimes it can just complete the next 3. That's great. To the point where sometimes when I don't have access to the AI and like I'm on a plane or something, I type and I'm waiting, come on, complete my thought, and it doesn't do that, and I realize, oh, I don't have the internet right now. When someone sends me some argument or paper, like I can ask an AI to summarize it. Yeah, it's just an extremely useful tool. I don't use it like when I'm trying to think of a problem, like I'm actually doing some deep thought and actually trying to solve a problem. I still use pen and paper. I've tried working on research level problems by directly talking to an AI, but it's the suggestions are they're still more unhelpful than they are helpful, and it's a little frustrating. They can't quite sync up with my thinking yet. But for all these secondary tasks, it's extremely useful.
So have you found any new aha moments during the past year?
In my research, well, yes, but in the old-fashioned way of working on a problem for months and finally sort of, actually, it's usually not aha, but oh my gosh, I was so stupid. How did I miss this? So you try to solve a problem and you tried 9 different techniques and they don't work. But because of that, you can see there's only one path left that could still solve the problem. And then you pick it. And once you see that, you say, oh, I couldn't, why did I even waste time on all these other approaches? But it was through the exercise of trying all these other paths and failing, that's how you learn how to find the one path that works. And AI still doesn't, it will suggest all kinds of random things, but it doesn't really learn. I don't know, I've not yet managed to use AI to solve problems directly. But once I have a problem, it helps me write things up. I can connect to literature. I can write some code to get some supporting numerics. So it is very helpful, but it's very complementary to, I think, the type of research what I like doing, which is solving the most difficult part of the problem.
Specifically, I'm curious about what will you prefer? Which models do you prefer in different scenarios? For instance, you mentioned that you will use AI on conjecture or literature search or just daily emails, I guess. Or do you have any suggestions that do you have certain AI tools that you find particularly useful?
I think basically for each person, they would want to use AI for the tasks that they don't want to do. But for the things that they enjoy doing, they would by hand. They would just keep doing it by hand. So for me, problem solving is something I enjoy doing, mathematical problem solving. So I will keep doing that. But digging through the literature to find was there any other paper that did a similar method to what I did. I'm very happy to have an AI just search through hundreds of papers to find any past literature. That for me is a perfect use case, or doing some long calculation. But for different people, it might be a different thing. What they find useful, AI useful for. It's a very broad tool.
In the past, you see that the math has always learned something from other disciplines. Especially, I guess it's your Lex Friedman show. You say math have learned something from physics. So how about this time? What has math already learned or might learn from the artificial intelligence?
Well, so I'm learning a lot about software development. There's a lot of parallels. For me, the future of mathematics actually resembles in many ways the trajectory of developing software. So if 50 years ago, software was written often by individual people, just writing a big program by hand and doing all the testing and they would have to generate all the images and debugging. But nowadays, software engineering is an industry. You have some people who write the code, some people who are developers, and some people who are user interface experts and quality assurance and whatever. So I think we are taking lessons from the software industry of what to do and also what not to do. There's also bad software practices. Yeah, so traditionally we had a close relationship with physics, but I think we are more and more talking to people in the life sciences and the social sciences who have much messier problems. The equations are not quite as clean and neat as in physics, but and much more data intensive. But maybe these AI tools are actually the right tools to solve these very messy, more real world type problems. Yeah, so it's a much more interdisciplinary time now. I think every subject, every science is talking to every discipline is talking to every other discipline now.
So I just noticed an interesting part. You say you are programming, right? You are doing more software.
I'm involved in a lot of projects where I feel like I'm a project manager sometimes. There are other people who are proving the theorems, and I'm just kind of coordinating and putting things together. It's an interesting role to be involved in a research project where I'm not actually doing much of the math, but I'm just inspiring everyone else to sort of do their best, and that actually it can work quite well actually.
Next question I want to ask, because we all know that the AI will not only lower the barrier of math, it will also lower the barrier of many subjects. You just mentioned software programming, but it might also lower the barrier of, I don't know, physics and chemistry. So I'm wondering that, does this trend inspire you or some other interests in other subjects?
Yeah, I'm certainly finding myself collaborating with people from many more diverse walks of life than I would have expected. So 10 years ago, basically, I only worked with other mathematicians. Occasionally, I would work with a statistician or an electrical engineer. But I'm meeting all kinds of people. Yeah, so especially industry and people like Chuck, for instance. It's, as I said, everyone's working with everybody now. So there's lessons to be learned both ways. I think there's a lot of sciences or other disciplines which can benefit from a more mathematical way of thinking, and mathematicians can benefit from a more grounded, real-world perspective on things. And now we have the tools that we can all understand each other and work together. So it's great.
So how does that feel working with people from different backgrounds, and what's the difference between that with the traditional research workflows?
Yeah, I certainly enjoy it quite a lot. I think there will still be, I should say, there is still room. I mean, there will still be people who are just domain experts and people who specialize in one subfield of a field and be the world expert in X. And we will still need those people. That's really important. But what is new is that these people can now work with other with other researchers who may not be experts in any one field, but they just see the big picture and they can connect with all kinds of things. So I've learned so much in the last few years about biology, science, economics, politics, funding. Some things I learned against my will, but I am finding that some of the lessons I learned in mathematics are unexpectedly transferable to other disciplines, especially things like the need for verification and how to think really, really clearly. Yeah, so I mean, it's a learning experience for me, but I'm definitely enjoying it. And I think people who have that broad mindset and are willing to always talk to other disciplines, they will thrive in this new era.
Actually, I think that what you just said really kind of also touched upon a point, which is the earlier point that we mentioned about democratizing, technology or AI for that matter. Is because you mentioned about like the fact is now with technology and also with and frankly, I think that's why I think with what we're doing with SAIR Foundation itself, we have the best minds in the different areas, and so I feel like we can just kind of a lot of these perhaps challenging problems, we know who are the right people because they're all working with us together, and so as a result of that, we we can kind of find quickly at least some of those challenging problems we're trying to solve. And they themselves may have solution, or they know, quickly, what other great minds who can work with us and quickly solve something quickly. So that's an example, I think, of democratizing, technology, democratizing AI as an example.
Yeah, traditional like funding agencies and universities organize themselves into departments. Have a department of mathematics, a department of physics, and so it's sort of naturally structured so that the mathematicians usually talk to mathematicians, the physicists talk to the physicists, and only very rarely do you have the interdisciplinary collaborations.
That's right.
Yeah, one thing I'm hopeful with SAIR, I mean, it has very deliberately has a very diverse set of advisors and interests, and we could make connections that other ways of other traditional ways of doing research might not do as often.
Yes, that's exciting.
Yeah, Terry, I'm glad to hear you there. You mentioned the traditional ways of higher education. That's actually the question I want to ask in the next part. So I want to start with Chuck first. So Chuck, how do you think in the age of AI, which qualities do you think will be more important for the university students?
Yeah, no, I think that's a great question. As Terry mentioned, and I've mentored many people over the years. And as an example, some of my PhD mentees and postdoc mentees, they told me that they're limited to say, maybe like 5, no more than 10, like advisors. Oftentimes it's really more like 3 to 5 realistically in terms of advisors they're working with. And the fact is, the way how we set up our structure, and I think Terry already highlighted that it's, we have, different expertise, and AI for science itself has, many disciplines. The fact is we're able to, like get so many, like great minds together. So the next thing is really, that's why I kind of point about the important thing about thinking critically, right? So even in the age of AI, when people ask like prompt engineering, but prompt engineering, in my opinion, it's really also about thinking critically about what are the problems that you're trying to solve, or you're trying to focus on the problem, right? So that you'd be able to get to exactly what you're looking for, right? So I think that critical thinking aspect, I think, is still very important aspect in the age of AI. But I also think that, I have also mentioned that in the days of AI, it's democratization of people who are not necessarily, I as an example, right? This is also speaking from personal experience, that I am a non-STEM major, right? I'm more on the business, as I mentioned before. But so I'm very hopeful that with, my skill sets, I be at least be able, I won't say that I'm as good as like people who are vigorously trained in engineering and all of that, but at least it will get me to a level where I feel like I can contribute. And I think that's exactly what we're trying to do, which is STEM versus non-STEM. Everybody can contribute to this whole effort of AI. And that's why AI and science, or AI and science kickoff, is so meaningful. And that's why SAIR Foundation is so meaningful for that matter. Right. Terry, I don't know, you want to add?
I agree. I think the new way of doing science, it isn't just technical skill, although that still be very important, but organizational skill, people skills, visionary vision, and knowing when to use the technology and when not to use the technology.
Right.
And I think many more people can contribute. I mean, there's a much larger set of people who like science and want to contribute to science than are trained as scientists. And so that's so AI has. I mean, we worry about AI making scientists dumber or making things too easy for people, but I think hopefully that will be compensated for by just the broader access that it gives.
Yes.
You just suggest some abilities that the young students should pay attention to in the future. So let's now talk about the education system. Okay, we all know that the current university and campus system is based on like the 200 ago. I don't know if it's last for a long time. So now it's a really big revolution coming with AI. How do you think higher education should adapt to this? Terry, why don't you go first?
Yeah, no, this is a great challenge, and I wish we had more time and less craziness to work this out properly. But yeah, we are in real time trying to figure out students who rely on AI too much. We are definitely seeing, first of all, they're getting excellent grades and not learning anything. And then the students who are trying their best to learn things the traditional way, but not using the AI, their grades suffer, but they're getting the better, they're learning more. So we need to rebalance that. We need to, so we need to teach our students how to use these tools responsibly or not to. I think we will have to have a lot more group projects, collaboration. As I said, this is one of the trends of the future. We need to integrate our courses with each other more. So currently, each course trains on one specialist topic usually, but I think we need to take a more holistic view of how we teach. Like we need to teach more general problem-solving skills, but somehow the way we've done it in the past is that we focus on one topic, and through the homework and the exams that we give them, they sort of indirectly learn how to study, how to deal with failure, how to deal with stress. It's not very organized right now, I think because many universities are too busy like just trying to keep the lights on and making sure that we can pay up our graduate students and whatever. But this is a very important topic. We will have to adapt, and people are trying many experiments. We don't know exactly what's going to work, what's not. But we've coped in the past. When computers came along, when the internet came along, we found out ways to change our education to adapt. When Wikipedia first came out, there was a brief phase where all the students would just copy from Wikipedia as their homework assignments, and we had to tell them not to. But we didn't say never use Wikipedia. Like it's very useful as a starting resource to do other research, but you should never stop with it. And so I think AI is very similar. Like I think these AI tools are a good starting point to do your research, but you should not just ask an AI, get the answer, put it into your homework, and turn your brain off. So we need to find the balance.
Education itself, perhaps maybe based on a few hundred years ago, 100, 200 years ago. And so inherently, I think universities right now are not changing as fast as industry. And that's why I think it's in the age of AI, that's exactly the point why SAIR Foundation finds an opportunity to combine both and learning from each other, getting both academia as well as industry coming together, right? So that we can learn from each other, because I have had the experience of working with a lot of entrepreneurs. And entrepreneurs inherently, they will find solution and problem solver. They are problem solvers, right? It doesn't, that there could be problems out there, but they just, they're going to be able to, whatever it takes, they will solve that problem. And that's exactly, I hope, that our new training, our training and college and universities were able to adapt using AI as a tool to ultimately solve problems, right? And also, I think on top of what's going on right now, I think education right now, and especially in developed countries such as the US, it's becoming very expensive, right? And so we think about, well, is it worth it? Like we're talking about like almost $100,000, right, a year, right? Education itself, like in many of the private universities, right? And so out the door, 4 years, that's $400,000. That is going to break the bank of the traditional middle class. And that is also something that I see as a major problem, right? If the trend continues, and people would say, well, why should I go to get a college degree, right? Especially now that we have AI. So I think that inherently we have a very good purpose, and it's also very mission critical that we be able to align with industry and really kind of understand, well, what exactly are the skill sets that you're looking for. And then perhaps, with academia, and in fact, that's the whole point why we actually have the industry panel. We have a higher education panel, by the way. We have the deans of all the major, I said Brown universities, UPenn, for instance, right? USC, and of course, UCLA. We have all these leaders in higher education coming together and say how we modify that so we adjust, right? And address those issues and those challenges that we face. And that's extremely exciting. And by the way, on top of that, I've already mentioned that we're very impressed with Open Mind, right? Which Sutton, I went to their winter school in Malaysia, and basically they're experimenting with the new ways of teaching. Right, and so one of the things that I'm very excited to explore, that is with SAIR and with IPAM and UCLA, we're looking at potentially doing something like summer school, right? And summer school would allow us to reiterate the training, the content quickly, so then we adjust instead of like under the pressure of that traditional structure, like during the quarters, you can change and whatnot. Summer school will be a great way to experiment new things so that we can adjust according to what is most important in AI. So I'm incredibly excited about all these things that we're doing in SAIR Foundation. And then of course, with this, really exciting initiative that we're doing. So more to come, guys.
Yeah.
Of course. So thank you so much, Chuck. I think you just described a really inspiring future of the education of the university. So now let's talk about the last question. Okay, I want to ask Terry to answer this.
Yeah.
So Terry, if AGI were really finally achieved and AI essentially become like a god of math, do you think we still need to learn math in the future?
Yeah, so AGI is such a nebulous, everyone has a different idea of what AGI is. Well, so maybe one analogy is with transport. Okay, so in the past we would walk everywhere, or maybe use horses or something. But at some point we developed cars and planes, which are much more efficient at transport than our legs. But we still walk. People enjoy running for sport and things like that. I mean, even if we get to a stage where science can be done much faster with tools like AGI than we can do unaided, I think we will still do. People will still do science the old-fashioned way, possibly more as a hobby. Just like people run now not as a job but for pleasure or for sport. And I also think that no matter how strong AI gets, I mean, there will be value that humans can add somehow. I mean, humans have such a very different way of experience of learning, in particular from AI. AI can crunch massive amounts of data to get conclusions, and humans can actually make very good conclusions from very small data and very little compute. And I think that will always have some value somehow. So I think we will find our balance. I think the scale at which we do science will be very, very different. So right now we work on solving one problem at a time. Maybe we're working on thousands of problems, millions of problems at a time, because maybe we solve one or two of them and then the AI just auto-completes the rest. That'd be great. Doesn't quite work like that just yet, but that could be the future.
The future is, I do want to say, the future is not just one Terry Tao. The future is 10,000 Terry Tao. That was what I think with AI, we want the brilliance in that. Yes.
Yeah, that's right, for sure. So that's really actually a good ending, right?
Yes.
So Terry, Chuck, thank you so much for the time today. And I must say, it's really a great pleasure to speaking with you today.
Yes.
Yeah.
Yes.
Yeah.
Thank you.
Thank you. Bye-bye.
Bye-bye.